Hello, this is Mr. Henry, and welcome to Lesson 5.3, Solving Linear Systems Algebraically. So, in the past two lessons, we looked at solving a linear system by graphing. So, it was pretty easy. We found where the two lines intersected. That was the solution. We also saw in the previous lesson that sometimes lines don't intersect. So, they either have no solution, if they're parallel, or they have infinitely many solutions if they're overlapping. This lesson will be a bit different. This is solving using algebra, like actually solving equations and doing step by step by step. The difference here is this will be better and easier if you don't have any graph paper. If you don't have any graph paper and somebody gives you a problem and says, what's the solution to the system of equations, you can't really do it very well without graph paper. But you can do it algebraically, and that's going to be the benefit here. Now, I understand it's going to be a little confusing at first as we go through, but it will get easier, okay? So the central question says, how do I solve a linear system algebraically? Oh, I thought of another negative of graphing to solve a system of equations. There are some graphs that don't end up at nice, pretty points. They end up like in the middle of a box, and you have to estimate that. Well, with solving algebraically, there's no estimation. You get exact answers. You might get 2.345 as the x variable. That's fine. You can't find 2.345 very well on a coordinate grid. Okay? So this is not really a did you know. It's more of an example of what the system of equations are going to be able to do for us here. So it says your mom sends you and your brother to McDonald's. She called ahead and ordered for a boatload of McNuggets. When you get there, they give you 3 small boxes and 2 large boxes of McNuggets, which is 70 total nuggies. They give your brother 1 small box and 3 large boxes of McNuggets, which also has 70 in it. The question is, how many McNuggets are in the small and large boxes? You can find out by using a system of equations. So we can actually set up this. So this would represent you, because you've got 3 large boxes and 2 small boxes, giving a total of 70. Your brother has 1 small box and 3 large boxes, giving a total of 70. And if you set up that system of equations and solved it, you would actually find out that the small box has 10 and the big box has 20. That would give you, and that would make these equations true, where each of you would have 70 McNuggets. And let's scroll down and see that big, huge pile of nuggets. Now, solving. There is no new vocabulary, so let's get into it. So the first method I'm going to show you, and actually the only method I'm going to show you, is called the elimination method. There are 2 methods. There is the elimination method, and there's something called the substitution method. I'm not going to show you both methods because why learn 2 methods when you can learn 1? I know I like to give options, and I like people to have a choice in what they learn. The problem is, both methods are fairly complicated. They're not super duper easy. There's lots of steps to them. And I found over my many years of teaching, most students prefer the elimination method. It will end up being less work most of the time. Okay, so I'm going to show you one method. It will work every time, just like the elimination method would work every time. But it's the one that usually gives you less steps, it's less work. So let's get to it. So here's the elimination method. So basically the way this works out is you need to have your 2 equations set up and down. See how they're set up, kind of like old school addition. The second thing that has to be true, apart from the equations are set up and down, is everything has to be lined up. My x's are lined up, my y's are lined up, my equal signs, my guys without variables, they're called constants, my constants are lined up. That has to be true too. So it's set up and down, my variables are lined up, and the last thing that has to be true for us is the number in front of one of the variables, they have to be the same number, like this is a 2 and this is a 2, and it's best if one of them has a different sign. So let me show you why all these things work out the way they work. What I'm going to do is I'm going to add these two equations together. And by add, I literally mean like old school addition. So I'm going to start over here, and I'm going to take 3 plus 1 is 4, 1 plus 1 is 2, 11 plus 13 is 24. I'm going to add my y's together. 3 y's and 5 y's gives you 8 y's. I'm going to add my x's together, and they cancel out. Positive 2x, negative 2x gives you 0x. Now, look at what happened. Our x variables eliminated. They are gone. I have no more x's. And look at the equation I have left. 8y equals 24. Is that really hard to solve? Answer is no. We divide both sides by 8, and y equals 3. I've now found one of my variables. Y is 3. I'm going to find the other. So the way we find the other variables, we have to take this and plug it into one of these equations and solve and find the other variable. This would be true no matter if you did the substitution method or the elimination method. So I'm going to take the top equation, which was 2x plus 3y equals 11. I'm picking it because there's no negatives. That's the only reason why. You could use the bottom equation if you want to. I'm going to plug in 3 for y. And I'm going to start solving. So 3 times 3 is 9. 2x plus 9 equals 11. Get rid of the add and subtract first. So I subtract 9 on both sides. 2x equals 2. Divide by 2 on both sides. And x equals 1. So I have, when my x value is 1 and my y value is 3, that is the solution to this system of equations. See? X is 1, y is 3. A solution to a system of equations is an ordered pair. It is a point. If I would throw these things into something like Desmos, play pretend. Here is not the right stuff. So let me put the right stuff in here. 2x plus 3y equals 11. That is my bottom equation I have here. And the other one, if I can scroll up, is, let's see, negative 2x plus 5y equals 13. And where do you think these lines are going to intersect? Well, they intersect at the point 1, 3, which is what we said is the solution to this system of equations. So proof that this is the solution. Okay, so we take the equations. I'm doing letter B now. We take the equations. We set them up and down. Boom. Make sure everything is lined up. X's and Y's and constants. Yes. We need one of the equations to cancel out when we add. If I would add right now, check this out. 3 plus 3 is 6. By the way, don't write this down. Don't write this down. 3 plus 3 is 6. 5 plus 2 is 7y. That plus that is whatever that is. I didn't eliminate one of my variables. I still have x's, I still have y's. I didn't do the right thing. I need one of my variables to cancel out. Now, how do we do that here? It's actually pretty easy. Do you see how these x's have the same number in front? If one of them was negative, let's play pretend. If he was negative, when I add here, my x's would cancel out. They'd be gone. We can make that happen. What I'm going to do is I'm going to take this top equation and I'm going to multiply everything by negative 1. Everything. All of them. All of them be multiplied by negative 1. Now what's going to happen here? So this positive 3 becomes a negative 3. Positive 2 becomes a negative 2. Positive 45 becomes a negative 45. That's what happens when I multiply by negative 1. It changes the sign of the number. So when I add now, check this out. 3 and negative 3, 0. Gone. 5 plus negative 2 is 3y. 72 and a negative 45. I don't know. Clear. 72 plus negative 45. Or you could also do 72 minus 45. See, same answer. 27. My x's are gone. I can continue solving this very easily. Divide by 3 on both sides. Y equals 9. I know the y coordinate of my answer is 9. To find the x coordinate, I'm going to take and plug my numbers back in. Now I can plug into this one or this one. Doesn't matter. So I'm just going to pick one. I'm going to pick the bottom one in this case. 3x plus 5y equals 72. I'm going to plug in 9 for y. Boom, boom. That's 45. Simplify. And solve. So I subtract 45 on both sides because we get rid of add and subtract before multiply and divide. 72 minus 45. Well, that should be 27, right? Right? So we did that here. 72 minus 45 is 27. And then we divide by 3 on both sides, and we get x is equal to 9 again. So the point 9, 9, when x is 9 and y is 9, both of these equations will be true. Okay, so for elimination, your equations have to be set up the same. With x's and y's and constants all lined up, your equal sign has to be lined up. You want one of the variables to have the same number out front. So in my first example, they both had a 2. Here, they both had a 3. And you want one of them to be a positive and the other to be a negative. Those are the 3 things we want before we eliminate. That's all the work, the hard work that we'd have to do. So like letter B here. Let's look at this. I have them set up. X's, Y's, constants. Problem. These are different numbers, and these are different numbers. So the way I'm going to fix this is I can multiply my equations by something to make them have the same number in front of a variable. So for example, maybe I'm looking at this and go, you know what? If I could make this in my head, if I could have this as a negative 12x, then these two guys would eliminate. That's my goal. I want this to be a negative 12x. Well, do you know what? What would you multiply this by to get negative 12x? You'd have to times by 4, right? So if we're going to multiply him by 4, we have to do that to everything. So I'm going to write a new equation over here. Negative 3 times 4 is negative 12x. 3y times by 4 is a positive 12y. 4 times negative 3 is negative 12. If I plug in everything else here, so this equation I multiplied by 4 gives me this equation. I multiplied everything, the entire equation by 4. Now, the bottom equation, I didn't do a darn thing to it. I left it the same. I left it alone. So my x's will cancel. Now, I feel like I should mention something here. I'm going to pull this off to the side. Let me group him. We're going to use, I'm going to finish this in a second. So don't erase, don't move, don't delete anything. But I feel I need to say something here. This is the third problem in a row now that we've eliminated the x variable. We don't have to eliminate the x variable. We can eliminate the y variable. Okay, I want to show what that would look like here. So for me to eliminate this y variable, what would I multiply this by and this by to make these y's the same? I don't have to multiply by the same thing. I can multiply the top by 2 and the bottom by 3. I just have to have the y's be the same. So you're thinking of the math term we're looking for. What is the least common multiple of 3 and 5? So you start going through your times tables. So 5, 10, 15. 15. I could multiply this by something and get 15, and I can multiply that by something and get 15. If I multiply this top equation by 5 and the bottom equation by 3, check out what this would look like. I would get, so I'm in my head, I'm doing negative 3 times 5 is negative 15. X plus a positive 15y equals negative 3 times 5 is negative 15. I made that piece a 15. Now, on the bottom, if I multiply everything by 3 and I get... I didn't actually multiply it. 36x minus 15y equals 99. If I would do my math here and I would add these together, my y's would eliminate. They're both 15. One's positive, one's negative. Both of these guys here, these would both give me the same answers. I would get the x variable, I would get the y variable. Okay? But I wanted to make sure it's clear you do not have to get rid of the x. You can get rid of either variable you want. Find the one that's easiest for you to get rid of. For me, here, x was easiest because I only had to multiply one equation by something to make these the same. Okay? So I'm going to take this. I'm actually just going to move it up here. So I'm going to continue solving this blue guy here. So if I solve here, these guys eliminated, like we said was going to happen. They're gone. I get 7y equals 33 and a negative 12. If I take 33 and I add a negative 12 to it, I get 21. Divide by 7, y equals 3. I would take that y equals 3 and I would plug it back into one of my equations. I'm going to plug it into the top one. Negative 3x plus 3y equals negative 3. Plug in y is 3, and there's a 3, and there's another 3, and yet another 3. And I solve. 3 times 3 is 9. Subtract 9 on both sides because you get rid of add and subtract first. Negative 3x equals negative 12. Divide by negative 3 on both sides, and x is equal to 4. So I got the point 4, 3. My x value is 4. My y value is 3. Boom. Now, to make sure that I'm not lying to you, I'm not, but just to make sure I'm not lying to you, I'm going to solve this red one here. I'm not going to do the whole problem, but I'm going to solve this one the way we have it set up. If I add here, these two eliminate, what's left over? Well, this side, 36 and a negative 15. 36 plus negative 15 is 21x, right? Yeah. On this side, 99 plus negative 15. 99 plus negative 15 equals 84. There's no y's. They're gone. So my equation is 21x equals 84. If I divide both sides by 21, these cancel. X equals 84 divided by 21. I know what that is. That's going to be 4. Didn't I say down here, didn't we show that the x value is 4? And then if I took this 4 and I plugged it into one of these equations for x, and I solved it, I'm going to get a y value of 3. Okay? So you can eliminate either variable. Do the one that's easiest. Here are 3 problems. Here's how I recommend you do this. Do letter D. Pause the video. Do letter D. When you're ready to continue, we'll go through it together. Once you've done that, then pause the video, go through letter E. Hit play, go through it together. Check to make sure it's right. Then letter F, okay? Do it one at a time. So go ahead, pause the video, do letter D right now. When you're ready to continue, hit play, and we'll go through it together. Okay. So hopefully you've done letter D by now. So let's see. I'm looking at these two equations. They are set up properly. My y variables have the same number in front, and they have different signs. This is perfect. These guys eliminate. Right now, if I add them straight up and down, they eliminate. I have 2x and positive 4. Positive 34 minus 30 is positive 4. Divide by 2 on both sides, and x is equal to 2. One variable found. Second variable. I'm going to take this 2 and I'm going to plug it into one of my equations. I'm going to use the top equation because there's just less negatives. So 5 times 2 minus 4y is equal to 34. That's 10 minus 4y is equal to 34. To solve, I'm going to subtract 10. Get rid of add and subtract first. Negative 4y is equal to 24. Divide by negative 4. Divide by negative 4, and y is equal to negative 6. So my solution is the point 2 comma negative 6. That is the x value and the y value that makes both equations true. First problem done. Now, if you haven't done so yet, pause the video, try letter E. When you're ready to continue, hit play, and we'll go through it together. Alright, so I'm going to move this junk out of the way. Letter E. So now these two are set up the same. They have the same x's are lined up and y's are lined up and that stuff's lined up. Problem is, well, my 4's, which is the same number in front, which is awesome, don't have the same sign. They're both negative. If I try to add them right now, I'm just going to get a negative 8. If I add these guys, I'm going to get a negative 4. None of my variables eliminated. So what I'm going to do is I'm going to take one of my equations and multiply by negative 1. I'm doing the top one. So if I multiply this by negative 1, it just becomes a positive 4. Negative y times by negative 1 becomes a positive y. Negative 36 times by negative 1 becomes a positive 36. And now when I go to eliminate, a positive 4 and a negative 4 cancel. A positive 1 and a negative 3, if I add, gives me negative 2y. And a positive 36 minus 28 gives me 8. Divide both sides by negative 2. Y is equal to negative 4. So I've now found my y variable. To find my x variable, well, I need to see my problem up here, so I'm going to get rid of some of this junk. I'm going to take my y of negative 4 and plug it to one of my two equations. Doesn't really matter which one, so I'll pick the bottom one. Negative 4x minus 3 times negative 4 equals negative 28. Tons of negatives everywhere. Alrighty. Simplify. That's a positive 12. Negative 3 times negative 4 is positive 12. Get rid of add and subtract, so I subtract 12 on both sides. These cancel. Negative 4x is equal to negative, I was going to say 38, but it's going to be negative 40. Divide both sides by negative 4, and x is equal to 10. So my solution is the point 10, comma, negative 4. So there is my x variable and my y variable that makes this equation, this system of equations, true. Group. Now, if you have not done letter F yet, now is your time to do it. So if you didn't do letter F yet, pause the video, try it on your own. If you did, well, we're doing it right now. So here we go. I'm looking at my two equations, and I see they do not have a common coefficient. That's the number in front of the variable. So my x's don't have the same coefficient. My y's don't have the same coefficient. So I've got to do a little bit of work here. Now I've got two choices. If I multiply this top equation times by 2, actually, you know what? Instead of 2, let's make it a negative 2. If I multiply this by negative 2, then he would become a negative 8, and then I could eliminate. Now remember, I'd have to multiply them all by negative 2. That is one possibility. If I multiplied my x's by negative 2, or multiply the top equation by -2, my x's would eliminate. The other option is I could multiply by -5. Check this out. If I multiplied by -5, this would become a -5y. Now I'd have to multiply everything by -5, but if I multiplied my top equation by -5, my y's would eliminate. I would have no more y's left. So I have choices. Now, the one that's probably easiest for me is I would multiply the top one by -2. So that's what I'm going to do. So when I do that, my new equation is going to look like this. I'm going to just write it down here. -8x minus 2y. That's -2 times by y equals -2 times by -30 is positive 60. So now, I don't need this equation anymore. Here's my new one right here. So I took him, I times by -2, and now he looks like this. He is transformed. And now I solve. My x's will eliminate. Boom. Gone. My y's, when I add, gives me 3y. That's 5 plus -2 is 3. My constants, when I add them, 60 and a -30 gives me a positive 30. Divide by 3, divide by 3, y equals 10. You notice I'm going through the easy stuff pretty quickly. It should be old news. We hopefully shouldn't have to walk through like solving a one-step equation. Now, when I take this y equals 10 and I want to plug it into one of my equations, I can actually still use this guy here. I can use any of them. I'm personally picking the ones that has the smallest number. That's why I'm mentioning this. That top equation, all the numbers are smaller. So if I plug in into that 4x plus y equals -30, if I plug in 10 here, I think it's just going to be a little bit less work. The numbers are a little bit smaller, a little bit easier. So I subtract 10 on both sides, giving me 4x equals, what is that? -30 minus 10 is -40. Divide by 4 on both sides, and x is equal to -10. So my solution is the point when x is -10 and y is a positive 10. They have the same solution. Okay. So now we've seen 6 problems of elimination. We've seen problems where they are lined up and have everything's like lined up, set up perfectly, where they have the same number but the sign's different. We've seen where they're the same number but the sign's not different, and we've seen where we had to multiply by something to make them the same. So what I'd like you to do is there's a little question on your notes that says, what does it take to eliminate one variable in a system of equations? Go ahead and try that right now. What does it take to eliminate one variable in a system of equations? Well, it takes those things we just mentioned. To eliminate one of the variables, your equations have to be set up the same. Here, let me get my typing in here. They have to be set up the same. That's one thing that has to be true. The next thing that has to be true is the variables have to have, one of the variables has to have the same coefficient. That's the number in front of the variable. So it has to be like a 3x and a 3x, or a 5y and a 5y. And the last thing we'd like is that same coefficient, we'd like one to be positive and one to be negative. Come on, fingers. I see. One coefficient is positive and other is negative. Okay? If those three things are true, then we just add the two equations together and solve, and it's easy peasy from there. Now, next example. This is where I would show you the second method. You see at the top it says the substitution method. The problem is, maybe you're just starting to understand the elimination method. I'm not going to switch to a new method that we didn't really understand the first one. And we don't have time, really, to go through and get extremely good at both of these. I'd rather just get really good at one than just okay at two. So let's focus on this same method. So what I'm going to do here is, you see, I have these two equations. I'm going to start by writing them. Well, I lied. I was going to say I'm going to write them up and down, but I'm not, because this guy here, I can see it. If I would write them up and down, they're not set up the same. I want to get him, this 3x, over that way. So what I'm going to do is I'm going to subtract 3x on both sides. Now what that's going to look like is going to look like this. Negative 3x plus y is equal to 2. He canceled out here. I can't add or subtract them. So there's my 3x and my y equals 2. I'm going to bring down my other equation. X plus 2y equals 11. And now they are set up to solve using the elimination method. The variables are all lined up. I'm going to look. Do any of my variables have the same number in front? No. Can I get them the same number in front? Yes! If my two options I see, if I multiplied this equation by 3, my x's would eliminate, because I have a negative 3 and a positive 3. If I multiplied the top equation times by negative 2, my y's would eliminate, because I'd have a negative 2y and a positive 2y. Those are both options. It doesn't matter which one you do, you're going to get the same answer. So, we do. Pick one. I'm going to pick the top one here. I'm going to pick multiply by the negative 2's, so my y's cancel out. So what that's going to look like, it's going to look like this. Positive 6x minus 2y equals negative 4. That's negative 2 times negative 3 is positive 6. Negative 2 times 1y is negative 2y. Negative 2 times 2 is negative 4. Now, since I chose this method, I'm not going to multiply by 3. He needs to stay the same so that my y's will eliminate. Check this out. My y's are now set up for elimination. They're going to cancel here. These are gone. Over here, I've got 7x equals 7. That's going to be pretty easy, right? X equals 1. Okay, I got one of them. So I know in my solution the x value is 1. So I'm going to take that 1 and I'm going to plug it in. I can use these equations or those equations. I'm going to use this bottom one here since it's right there. 1 plus 2y equals 11. I subtract 1 on both sides. 2y equals 10. Divide 2 and y equals 5. Boom. Answer. So even though this problem was set up for the substitution method, it still was pretty easy to solve using elimination. We had to do a little bit of manipulating to move this guy over to that side. We had to make one of the variables have the same coefficient in front, but that's just part of the elimination method. Okay? I'll tell you what, the substitution method wouldn't have been any easier. It's not any shorter. In fact, this is shorter than the substitution method would have been. Letter B. I definitely don't want to solve that using the substitution method. Check this out. These guys are set up the same. Well, you don't even know what the substitution method involves, but trust me, this is easier using elimination. They're set up the same. If I write down these two equations, 3x minus 2y equals 12, and 3x minus 6y equals 36. Boom. I just wrote them both down. Top one, bottom one. My x's, well, my equations are already set up the same. X's and y's and constants. They're both in standard form. My x's have the same number in front. That's awesome. The problem is, where the only small thing that is different is they both are positive. I want one to be positive and one to be negative so that when I add them, they cancel out. So how do I change the sign of one of them? I multiply by negative 1. I'm just going to multiply the top one by negative 1. So it becomes a negative 3x, a positive 2y, and a negative 12. I multiplied by negative 1 on each of them. So now if I add here, my x's cancel. My y's, well, 2y minus 6y is negative 4y. And negative 12 and a positive 36 gives us a 24. I then divide both sides by negative 4, and y is equal to negative 6. My y part of my answer is negative 6. I'm going to take that negative 6 and plug it into one of my two equations. It doesn't matter which one, just pick one. Since I got space here, I'm going to use this one. I'd like to use that one because the numbers are smaller, but I've got stuff in the way. So I'm just going to use this one over here. 3x minus 6 times by negative 6 is equal to 36. X is going to equal maybe 0? Let's see. 3x and then negative 6 times by negative 6 is a positive 36. And then when I subtract 36 on both sides, not 3x, 36, these guys cancel. 3x is equal to 0. Divide, divide, x still equals 0. There's my x value. So when x is 0 and y is negative 6, these two equations have the same value. Now, we haven't Desmosed one of these things in a while, so let's show and prove that I'm not lying to you. So 3x minus 2y equals 12, and 3x minus 6y equals 36. Alright, let's see. Do they cross at the point 0, negative 6? Why, yes they do cross at the point 0, negative 6. Okay. Letter C. I would like you to try this one. So I'd like you to take these two equations, set them up, and solve them. And when you're ready to continue, hit play, and we'll go through it together. Okay, so you hopefully noticed that these two guys are not set up the same. This is in standard form where the x and y are on the same side. This is not. So I'm going to start by subtracting x here to make this negative x plus y equal to negative 7. Now my x and y are on the same side. I can't just drag him, so I'll have to be a caveman and write it out. 2x plus 3y equals negative 1. By the way, it does not matter which one you put on the top or the bottom. Alright, so I'm looking at my equations. They are now set up the same. Check. Do they have the same number in front of one of the variables? No. Can I make it? Yes. So choices. I can eliminate my x's by multiplying this bottom equation times by 2. If I did, he'd become a negative 2, and I could just cancel them out. Or, I can make them both have a 3. Why? If I multiplied my bottom equation times by negative 3. Do you know why I'm saying negative? Because that way I have a negative 3 here, and a positive 3 and a negative 3 would cancel. Now, I like that one best. So I'm going to do that. I'm going to multiply this bottom equation by 2. And this guy, he's just staying the same. So I'm going to have 2x plus 3y is equal to negative 1 on the top. And negative 2x, I multiplied negative 1x times by 2, plus 2y, that's y times by 2, that's this, equals negative 14. Now my x's will eliminate. My y's just combine, give me 5y, and this gives me negative 15. That's a nice little one-step equation. Divide by 5 on both sides, and y is equal to negative 3. I'm going to take that y, well, first off, let me get him ready. Negative 3 is my y or the y variable. If I take that negative 3 and plug it into one of my equations, I'm going to use this guy right here because he's right here. Negative 3 equals negative 7 plus negative x. And solve. I'm going to add 3 to both sides. Negative x is equal to negative 4. I'm going to divide by negative 1 on both sides because it's a negative x, giving me x equals positive 4. So the point 4, negative 3 is the solution to this system of equations. It is the line where they both intersect. Letter D. One for me to try. Okay, so I'm looking at it. They are not set up the same, so I'm going to work at it. I'm going to add 4y. So I have my x's and y's on the same side. Now, if I write it like this, maybe you did this. I'm doing something intentionally slightly wrong here, so you might want to hold off on writing. If I did this, there's a problem. My x's and y's are backwards. They're not lined up with each other. When I added this 4y here, some people would put their y first, but now they're not lined up. I can switch them. I can keep the x first and put this positive 4y second. That's allowed. Now look, my x's are lined up, my y's are lined up. Now I can eliminate. Okay, so I have them set up the same. Step 1, check. Step 2, get them the same number in front of one of the variables. So what do I want to do? Well, I've got choices. I can multiply the bottom guy to make my y's cancel out. I can multiply the bottom guy by 4, because then I'd have 4y and negative 4y. They would eliminate. Or I could multiply the top guy by negative 5, because positive 5. Because if this is a positive 5x and this is a negative 5x, my x's would cancel. Choices. You can do either one. It doesn't really make much of a difference. Okay? I'm going to multiply by 5, just because. So I'm going to take this top equation times by 5, the bottom equation times by nothing. So he stays negative 5x minus y equals negative 43. Up top, 5 times x is 5x. 5 times 4y is a positive 20y. 5 times 39, I don't know. 39 times 5 equals 195. Now, when I eliminate, these guys cancel out. 20y minus y is 19y. 195 minus 43, calculator. 195 minus 43 equals 152. To solve, I divide by 19 on both sides, and y is equal to 152 divided by 19 equals 8. So even though that looked like it was going to come out ugly, we still got a nice pretty answer, 8. And, well, let's take that y and plug him in. So I'm going to do this equation because he's right here. So my y variable is 8, negative 43, negative 5y, and solve. So I'm going to start by adding 8 to both sides because we get rid of add and subtract first. So negative 5y equals negative 43 plus 8, negative 35. Divide by negative 5 on both sides, cancel him out, and y is equal to a positive 7. Whoa, 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 whoa. Oh, that's supposed to be an x, right? That's my x variable, not my y variable. X is equal to negative 7. I was like, wait, well, I have two y's? So my solution is the point when x is 7 and y is 8. Letter E. Only 2 left. This is letter E, and we've got a letter F, and then we're done. Letter E, go ahead and pause the video, try this problem on your own. When you are ready to continue, hit play, and we'll go through it together. Okay, so we kind of got to do the same thing. We gotta get this x over on that side. So I'm going to add x to both sides. That gives me, I'm looking at this equation. If I put down x plus y equals 7, check this out. They're not, the x's and y's are kind of backwards of each other. So I'm going to switch it. I can do that. I just have to have these two pieces down here. So I'm going to make this, not scribble over it, I'm going to make this a y plus x. Come on, there we go. Group, now you're not so ugly. Beautiful. Ain't you a beaut? Alright, there we go. Everything's lined up now. So, I can make my y's cancel by making this play pretend. If this was a -5 out here, my y's would cancel. That's one thing I could do. I could make my x's cancel if this was a -4x. My x's would cancel. But I'm just going to multiply by -5. To make this a -5y, that's what I want to get. So I'm going to multiply by -5. So when I multiply by -5, I'm going to get -5y minus 5x, because -5 times by x is going to be a -5x equals -35 on the bottom. Up top, 5y plus 4x equals 32. Boom. And eliminate. Y's gone. X's -1. Constants -3. Divide by -1 on both sides. X is equal to +3. So I know in my solution the x value is 3. To find the y, I can plug this 3 into any of the equations I have. I'm going to use this guy because he's easy and he's right here. So y plus 3 equals 7. Remember, my x value is 3. If I subtract 3 on both sides, y is equal to 4. Solution. Last problem. Go ahead, set it up, solve, and you're ready to continue. Hit play, or if you get stuck, hit play, and we'll start going through it together. Okay. Now, here, our equations are actually kind of set up the same. X equals -2y minus 6 is the first one. And x equals -y plus 2 is the second one. They are set up the same. They're not the way we're used to seeing them, but they are set up the same. We could actually solve this using the same elimination method. To do that, I still need one of the variables to cancel out. Well, which one would you like to cancel out? Choices, choices. Oopsie, undo. You could multiply one of them times by -1 to make it like a -x, and they would eliminate. Don't do it to both, but you could do it to one of them. That's one choice. The other choice is if you want your y's to cancel out, you could multiply this bottom guy times by 2, and it would become a 2y. If you make a -2, it would become a +2y, and they would cancel out. Most people would probably just multiply one of these guys by -1. So let's do that. Top, why not? Times by -1. So now he becomes a -x, he becomes a +2y, and he becomes a +6. When you multiply by -1, it just changes the sign of the number. So now when I eliminate here, -x plus x is 0. That's okay. Don't get freaked out by that 0. Here, 2y minus y is 1y. You can put the 1 if you want to. 6 plus 2 is 8. It looks different than we've looked at before, but it's no harder. I mean, it's what, one extra step? Subtract 8 on both sides. 1y is equal to -8. We still were able to solve this little dinky equation pretty easily. It was a little bit different, but it wasn't hard. So we have our y value is -8. We got to find our x value. So I'm going to take that -8 and I'm going to plug it into one of my equations. I'm going to plug it into this first one here because I like him. He looks pretty to me. So I'm writing it down first. Plug in -8 for y. Multiply. That's 16. X is equal to 16 minus 6. X is equal to 10. 16 minus 6 is 10. And I have an answer. I found my x value is -8. My x value is 10. My y value is -8. And I'm done. Okay, so I've shown in this lesson how to do the elimination method for all of the problems. So this summary doesn't make much sense to you. So it says, which method of solving equations algebraically do you like best? Well, I only showed you one. I only showed you elimination. So maybe which setup of the equations do you like best? We had a whole bunch of different setups. What would you like the equations to look like to get them to eliminate? Okay. This has been lesson 5.3. Thank you for watching.